So, very good morning to you all. Today, we are going to start again one of the important topic of quantitative techniques for manager, and the topic is game theory. The topic is game theory. I'm your instructor, Dr. Ritesh Singhal, and we'll discuss the important aspect of game theory, and we'll solve few problems also in this particular video. So let's start. As we discussed in previous classes also, that the theory of game is a situation where two or more players competing with each other with some conflicting interest. So here two players or two brands or two companies usually fight together to winning some market in a game situation. So here we have to identify the probability of winning, probability of losing, and probability of different situation to identify the winning and losing chances of both the players. So we have two types of game basically. Number one, the game related to pure strategy and the game related to mixed strategy. So the first and foremost identification of pure strategy game is that there is saddle point exist. We have done these question in previous videos where saddle point exists. What is saddle point? Saddle point is a position of a matrix where row minimum coincide with column maximum. That is called a pure strategy game. Here, a single strategy is always best in all situations. So only single strategy is sufficient to administer the game. But in case of max strategy game, it is it is advised to the player that they should use not a single strategy, but use this strategy in a mixed format, like sometime used strategy one, sometime used strategy two, with some probability also. So mixed strategy game here, the decision rule which always select a course of action for each of the player in accordance with some probability distribution. So word probability comes here. Here the result obviously be there, but with some probability. You are generally, you can say, suggest the players that you should use these strategy with some probability. And the a point of identification here is the saddle point usually not exist in case of mixed strategy game. So in previous videos we discussed pure strategy game. Now today we are going to discuss in this video specifically focused on mixed strategy game. So let's start. So before solving this mixed strategy game, we should understand that if we have a matrix, if we have a payoff matrix of a game of size n by m, in that case, first we reduce this matrix into 2 by 2 using dominance rule. So there is a rule called dominance rule which usually reduce the order of the matrix from n by m to 2 by 2. And after that, we have an analytical formula to solve this game and we get results. So dominance rule does not gives you the result directly, but definitely it will reduce your gain matrix into a 2 by 2 matrix. And after that, we have a formula that is called analytical formula, and we get the results. So what is dominance rule here? Dominance rule. So I think you understand the way we are going to solve the problem. First, we have a matrix, then we need to reduce this matrix into 2 by 2, and then after that we get results. So this is a journey, this is a way to get the results. So dominance rule, the thing now comes into mind, that what is dominance rule? Dominance rule means here we used to compare two rows, that is the two strategy of player 1, and if suppose first row is greater than equals to second row, then we usually remove the strategy which is having lower values, or the row which is having lower values. Similarly, in terms of columns, that is the strategy for player B. If C1 is greater than equals to C2, in that case, we'll remove the strategy which is having greater column values. Okay, so you should remember here that in case of rows, we usually dominate the row which is having lesser values. In case of columns, we usually remove the columns which is having greater values. Okay, so now let's take one example to understand how the dominance rule is applied in different situations and how we can solve a problem of mixed strategy game using dominance rule and analytical formula to ultimately get the results. So let us discuss this game. It is advised to the students that they should uh, first use saddle point before solving a game, because if saddle point is there, then there is no use of dominance rule. There is no point to start solve the question using dominance rule. Okay, so first it is advised that you should use saddle point, and I think you know what is saddle point. Saddle point is a situation where row minimum coincide with column maximum. So first we have to check this saddle point. So in first row, the minimum value is -7. In second row, minimum value is -6. In third row, minimum value is -7 again. Column wise, in first column, maximum value is 9. In second column, maximum value is 8. In third column, maximum value is 4. Okay, so I think you may have seen that there is no common point where row minima coincide with column maxima, and you can say there is no saddle point exist. So this is not a pure strategy game. This is an example of a mixed strategy game. If saddle point exists, then we can say this is a pure strategy game. If saddle point does not exist, then we can say it is a mixed strategy game. And now we have a different formula, different method to solve these kind of game. And you know, we have a method called dominance rule here, and then analytical formula, which we are going to solve the particular game. So let's remove all these things here because I need to calculate few more things. Okay, now what is dominance rule? Since uh, saddle point is not there, then we should apply dominance rule. So compare any two rows. For example, if we are going to compare row A1 with row A2, so 9 is compared with 3, obviously 9 is greater. 8 is compared with -6, 8 is greater, but 7 is lesser than 4. So we can say that the comparison of first and second row is not possible. Comparison of first row and second row is not possible. So we have to choose another option. We have to choose another option here. So let compare row 2 and row 3. Row 2 and row 3. 3 is less than 6, good. -6 is less than 7, very good. But 4 is greater than -7. So here rows second and row third could not compare with each other. So we need to try another combination. So we'll remove all these things here and we'll try another combination. So another combination left here is A1 and A3, first row and third row. Here 9 is greater than 6, very good. 8 is greater than 7, okay, and -7 is equals to -7. It means we can say that A1 values of A1 is greater than equals to values of A3. And in case of dominance rule, we'll remove the rows which is having lesser values. So we are going to remove third row. So third row is to be strike off here, and the game is now reduced with one row. Now we'll try to reduce this game further till we get a matrix of 2 by 2. Now compare with columns. Compare B1 and B2 here. So 9 is greater than 8, okay. 3 is greater than -6, very good. So we can say b1 is greater than equals to b2, and you know, in dominance rule we'll remove a column which is having greater values. So here we are going to remove column first, that is b1. Now the remaining matrix looks like this. We have only four uh, values here, like this. This is the remaining matrix here, 2 by 2, only four elements. Okay, now the purpose of using dominance rule is over. Why? Because dominance rule reduce the matrix of 3 by 3 into 2 by 2. Now the next step is to solve this particular game using analytical formula. So analytical formula look like this. This is our final uh, matrix, which looks like this. It is a 2 by 2 matrix, obviously. Now we are going to use analytical formula here. So friends, uh, what we do, we here we apply analytical formula. This is our matrix which left here. I think you can compare this matrix with this one. This is the matrix. Yes, here it is. So this is the matrix left. It is a 2 by 2 matrix, and I think you may have understood that this particular cell is called A11, this particular cell is called A12, this is called A21, and this is called A22. So there are four values: A11, A12, A21, and A22. Now what is x1 and y1 here, x2 and y2 here, that we need to discuss here before going to solve it further. Here x1 is the probability of using, let's discuss in this slide. So since A3 is not there, B1 is not there. So let us assume that x1 is the probability of using the strategy A1. X2 is the probability of using strategy A2. Similarly, Y1 is this probability of using strategy B2, and Y2 is the probability of using strategy B3. And you know, when we say it is probability, x1, x2, y1, y2 are probability, it means the values of these four variables must be between 0 and 1. So what is the thing here? We need to calculate. One more thing we should keep in mind here, that x1 plus x2 must be 1 and y1 plus y2 must be 1, because the player has to select any strategy, either A1 or either A2. Okay, so x1 x plus x2 is 1 and y1 plus y2 is 1. So now we need to calculate the value of x1, x2, y1, y2, and v, that is value of the game here, using this particular formula, and this formula is called analytical formula. So here calculate x1, a22 minus a21. Here every value of this particular a12 is a21 is given in this small matrix, 2 by 2 matrix. And one important thing you should, I think you find you can see or you can observe here, that the value in the denominator or the function in the denominator is same, whether it is x1, whether it is y1, whether it is v. So no need to calculate denominator again and again. You calculate it once and use it again and again in different formulas. So after putting all the values here in this formula, we'll have the value of x1 as 2 by 5, value of y1 as 11 by 25, and similarly using this equation, since x1 plus x2 is 1, so we can have a value of x2 as 3 by 5. How? 1 minus 2 by 5, that is 3 by 5. Okay. Now the value of y1 is 11 by 25. So it means the value of y2 would be 14 by 25. And value of the game, that is the important parameter of this particular game theory, is 2 by minus 2 by 5. And this minus 2 by 5 indicates that since it is less than 0, since it is negative, then it is found that this game is favors to player B. because it is negative. If it is positive, then obviously it has to support the pair A. So now what is my final result? Because I need to collect all the result in one sheet. So how to write the results? We can see here. Since these two strategies are removed, so probability of using these two strategies are obviously 0. Now write the values here in this sequence, that optimal strategy for player A is 2 by 5, 3 by 5 and 0. Mind it, 0 is putting 0 is here at the third position, because you here you remove third row. That is why 0 is kept at third position. Here B1, that is first column, is being removed. That is why I should write 0 in beginning, then y1, then y2. And value of the game is of the negative, that favors to player B. That is our final result. We should write the result in this format only, exclusively tell about all the strategies given in the question, whether it is removed. So all the removed strategies must be written here in sequence with 0 probability. Okay, I think you understand this particular situation. Now we'll take one more example so that you maybe understood the things in a better way. Let's take this example, example 7. It is there on page number 819 in your book Andy Vora, which is, I think, available with you. The question is like this: a small town, in a small town there are two stores handle sundry goods. The store names are ABC and XYZ. So obviously there are two competitors, ABC and XYZ. The total number of customers is equally divided between the two. Both of these store plans to run sale on during Diwali season. Sales advertise through newspaper, radio, and television. The payoff matrix is given below. Determine the optimal strategies and value of such gain. So these are the strategies for competitor or the player ABC. Strategies like newspaper advertisement, radio, and TV. And the same strategy is available for XYZ, strat X, Y, and Z. So I think you know this matrix. This is a 3 by 3 matrix, and it is advised before solving this particular game, it is advised to check saddle point, of the game. So I think you can check it, and first row minimum, second row minimum, third row minimum, first column maximum, second column maximum, third column maximum, and you found that there is no saddle point exist. So what we do, we'll use the another option, that is dominance rule here. So I think I need to remove all the links here. Yes. Okay. Now what we do, we'll use dominance rule here. Dominance rule reduce this game into 2 by 2 game. So compare any two rows here. So let's take first two rows. 30 is greater than 0, okay. 40 is greater than 15, okay. But minus 80 is less than 20. Okay. So first two comparisons are not possible. So let's remove this. Try another combination. Let's consider second and third row. 0 is less than 90, okay. 15 is less than 20, okay. Minus 20 is less than 50. So now it's okay, and we can say like this, less than. So we can easily remove second row here, and it looks like this. Second row remove. Yes, this one I need to remove. Now compare column wise. Take first two columns, 30 and 40. 40 is greater. 20 and 90. 90 is greater. So no comparison. Compare second and third column. 40 is greater than this, but 50 is greater than this. No comparison possible. Try another combination for first and third column. So 30 is greater than 80, very good. 90 is greater than 50, very good. So we can say C1 is greater than equals to C3, and we can remove C1 here. So your remaining matrix looks like this one, first column. So only 4 values are left. That is a 2 by 2 matrix are left. And again, in the same manner, we can use analytical formula here. So let's use analytical formula. This is the matrix remaining. Although I am not removed the name of this strategy because name of this strategy is still there. Yes, this is my remaining 2 by 2 matrix. Now value of x1, y1, x2, y2, and v. Okay, so x1 is 1 by 5, and similarly x2 would be 1 minus 1 by 5, that is 4 by 5. Similarly, 13 by 15 is y1, and we can find y2 using 1 minus 1 by 13 by 15, that is 2 by 15. And value of the game is 24. And you know it favors to player A, B, C. So, but this would not work here. We should write the result in the desired sequence, in the desired manner. And the desired manner is like this. Optimal strategy for competitor ABC is 1 by 5, 0, and 4 by 5. It means we advise that not to use the strategy for radio for ABC, and for XYZ not to use a strategy for newspaper. So 1 by 5, 0, and 4 by 5 for competitor XYZ. 0 is written for newspaper and television, sorry, radio and television. So this is nothing but the probability that out of 15 times, 13 times he should select the strategy for radio, and remaining 2 times select this strategy for television. And value of the game is 24. It is a very good amount, and this game is purely favors to player ABC, or we can say player ABC is on the winning side in this game, and accordingly they should take decision. They should take their own decisions. And this is about the game of pure strategy. No, mixed strategy. Mixed strategy game. Because here more than one strategies are to be advised to be used by the players. Okay, so students, I think you understand this thing, and what we discussed today, let's summarize it. We just discussed today the 2 types of game, that is pure and mixed strategy. We focused on mixed strategy here today. We use dominance rule. Dominance rule is used to reduce the matrix of any order into 2 by 2. And then further, we can use analytical formula. This is the analytical formula to solve the game. And here we discuss 2 different example which does not have saddle point. How it is always advise you to please check saddle point before using dominance rule. Again, we use this. I advise you that you should write the result in this sequence. We have taken another example of 2 brands of 2 stores and their strategies, and finally we got the results and advised both the player with their optimal strategy. So thank you, friends. Thank you, students. And I hope you understand the session. We'll have another video in the next class, and we'll meet here. Till then, goodbye.